Now, good morning. I'm going to go through the homework solutions that you had for work on Thursday. And you had questions 1, 2, and 3 on page 137. So I'm going to look at question 1. You're asked to copy this table into your homework copies and then complete it. So it's breaking things down for us to help us remember what we're doing with probability, number of trials, expected frequency. So a quick reminder then again, the expected frequency, how many times we expect something to happen, is always going to be the probability multiplied by the frequency. How many times did it happen? By the frequency, sorry, by the number of trials. So how many times did we try something out? Multiply that by the probability and we get the expected frequency. So let's fill in this table then. In A, the probability is 0.18, the number of trials is 100, we multiply them together and my expected frequency is 18. So whatever that event is, we expect it to happen 18 times. B, 1/20th, and we're multiplying by 260. You can write that down or you can just do it in your calculator. 1/20 multiplied by 260, and that gives us 13. So we expect this to happen 13 times. 0.73 and 3000, again, we're just multiplying it, and there's no harm in using your calculator for these types of calculations. I did 300 accidentally, 3000, and we get 2190. I do need to see you write down this equation, but I don't need to see any working out beyond the calculation being correct. Again, this one, 2/3 of 660, 6600, 6600, and that gives us 4400. Divide by 3 and you multiply by 2 if you're doing it without a calculator. Now, that's fine, but now we're stuck, right? Something multiplied by 1500 will give me 30. So how do I work out what that fraction was? Well, if we look back here, 18 divided by 100 gives me 0.18. I'm sure this took some thinking for some of you, and hopefully some of you were able to work this out. So 18, working backwards, 18 divided by 100 gives me 0.18. 13 divided by 260. Let me show you on my calculator. 13 divided by 260 gives me 1/20th. So working backwards, same thing here, divide this by this, you'll get 0.73. Divide this by this, you get 2/3. So for this one, 30 divided by 1150, 1500 I mean, gives me 1/50th. Now, I can write that as a decimal, or I can write it as a percentage, 0.02 or 2% or 1/50. We might as well just leave it as a fraction, 1/50. Okay, but now this one. How do I work out what this is? Well, I divide the other way. So 18 divided by 0.18. Okay, I divide by the other number. Again, divided by. So if I have 18 divided by 0.18, I get 100. Let's see this one. 13 divided by 1/20th. Seems a bit weird, right? But we can do it. It's the same as multiplying by 20. 13 divided by 1/20th. The calculator can do this work for us. It gives me 260. Same thing here. Even if it's a fraction or a decimal, so divided by here as well. 4400 divided by 2/3. 6600. So 200 divided by 0.16. Divide by 0.16 and we'll get our answer. 200 divided by 0.16. 1,250. It's okay if not everybody got those last two to work out, but I would hope that everybody would be able to do these questions here. And you look up the answers in the back of the book. If you need these answers for the next part, you come back and just use the answers from the back of the book, even if you couldn't do the work. Okay, please do let me know if there's anything here you don't understand, especially for the first four. So I would hope that everyone would be able to do these first four calculations for expected frequency. Working backwards, that's a little bit trickier. So if you got stuck on that, that's okay. Now, part B. A spinner with equal sectors is spun. Each sector of the spinner is coloured blue, red or green, and they're equal. Okay, an equal spinner means it's divided into thirds, blue, red or green, and the probability of each is going to be 1/3 because they're equal. The probability scale here shows 20 equal sectors. I apologize, guys. That was me not reading the question correctly. A spinner with 20 equal sectors is spun, and each sector is coloured blue, red or green. So we don't know how many of them are blue, we don't know how many are red, and we don't know how many green. But the probability scale shows us the probability of each of them. Now they've filled in only part of the probability scale, so let's do the rest. That's 0.1, 0.2, 0.3, 0.4, 0.5 is done, 0.6, 0.7, 0.8 and 0.9. And we have to work out how many sectors are coloured each of these. So what we know is that the probability of it landing on blue is 0.1. And we want to say how many of them are blue. So in a way, we're looking for the expected frequency. 0.1 of the sectors, 10% of the sectors, of the 20 sectors are blue. And of means multiply. So it's 0.1 multiplied by 20. 0.1 by 20 gives us 2. 2 blue sectors. And you could have done this by trial and error as well. 2 out of 20 gives me 1/10, which is 0.1. So that's correct. And you could have done this by trial and error as well, trying out different numbers until you got your 0.1 probability. How many of them are green? Sorry, how many of them are red? Again, we're told the probability of red, and that's 0.6. And then you multiply that by 20. So 0.6, 60% of 20 is 12. 12 red sectors. They don't tell us the probability of green, but we know that all of the sectors add up to 20. So that means that 2 plus 12 is equal to 14 is blue and red, and 20 minus 14 equal to 6. There must be 6 green sectors. So we can logically work out that the remaining sectors are green. So there are 2 blue, 12 red, and 6 green, and they add up to a total of 20. And the probability of blue, 2 out of 20, 0.1. Probability of red, 12 out of 20, 0.6. And what's left then? The probability of green would have to be 6 out of 20, which is 0.3. We weren't asked for it, but we could calculate it if we were. Okay, let's move on to questions 2 and 3 then. Question 1, it's not that the maths was hard, and this is what happens sometimes, unfortunately, is just understanding what we're asked. Question 2, a fair six-sided die is thrown 6,000 times. So my number of trials, the number of times I did something was 6,000. Find out how many times we'd expect to land on the number 1. Well, the probability of landing on the number 1 is a 1 in 6 chance. So the expected frequency, we expect 1/6 of 6,000, 1,000 times landing on 1. Part B, we're asked how many times we would expect it to land on an even number. Well, the probability of it landing on an even number is 3 out of 6, or a half. So we would expect half the values. Half of 6,000, 3,000 times landing on an even number. Okay, so that's a very straightforward expected frequency. I would hope that everyone, this is another everyone question. So if anyone can't do this, you need to let me know so that I can help you with whatever it is you're not understanding. Question 3 then, an unfair coin. Okay, this is interesting. So it's unfair, it's biased. They're not going to be equal probabilities. But we are told that the relative frequency of landing on tails is 0.35. So now I would expect we can use this as a probability. So remember, relative frequency is a probability, especially for biased things. Relative frequency is experimental probability. It's an estimate of the probability. So we can use it as probability. Okay, that's really important. So we can use it for expected frequency, and we say we expect 0.35 multiplied by the 600 trials. And use our calculator for that. 0.35 by 600, and we get 210. We would expect 210 heads. Not heads, tails. Tails. We would expect it to land on tails 210 times. Okay, so again, now this one was harder, but I would still want everyone in the class needs to be able to do this type of question. Now, you may have gotten stuck, so that's okay if you didn't maybe realize that relative frequency and probability, they're synonymous. They can interchange them, especially in questions like this, where we have something that's biased. Okay, so please do let me know if there was any part of this you didn't understand. Today, all I'm going to ask you to do is a little bit more practice with this same topic. So the questions are going to get harder, which is why you need to let me know if you're getting stuck. Okay, thank you.